For the following exercise, solve the quadratic equation by completing the square. Now, in order to use the process of completing the square, what we have to do is first, when we notice that we have a quadratic, the very first thing we should do is try and get everything to one side and see if it will factor. If we notice that it won't factor, or if it's difficult to find what the factors are, then we would start using a more advanced method like completing the square or the quadratic formula. The problem with completing the square is in the setup process, we're required to divide everything through by the coefficient of the squared term. That's going to give me a fraction like 5/12, and then I have to work with that. So to be honest, that isn't the best method that I would use here. I only use completing the square when that linear term is going to end up being uh, anything but a fraction. If it ends up being a fraction, I generally avoid completing the square and either try to use factoring or the quadratic formula. Since we didn't try factoring, let's see if that will work in the first place. So what we need are two linear functions that multiply together and give us this quadratic. So the first term, 12b squared, we need two things that multiply to 12b squared. So I think I'll try 3b and 4b, because those two multiplied together certainly will give me 12b squared. Now I could have tried 2b and 6b or 1b and 12b, but I generally go for the ones that are closest together first. I don't know why, but it seems like most math problems that's the case. Now, things that multiply together to give me 3. I've got 1 and 3, so here's the thing. I can either put 1 here and a 3 there, or I could put the 3 here and the 1 there. The reason I am not going to choose this way is because this would make a common factor in this first linear term. And if I had a common factor here, then I would have had a common factor in the entire quadratic. But since that's not the case, that tells me right away that I don't need to try that set of combinations. So let's see what happens here. If I multiply together 1 times 4b, that would be 4b. And then 3 times 3b would be 9b. And I'm trying to get these to add up to positive 5. And if the 9b is positive and the 4b is negative, I think I can make that happen. So let's see what happens with the rest of it. If these two need to be positive, I need a plus here. If this needs to be negative, I need a minus there. So 3b times 4b is, of course, 12b squared. negative 1 times positive 3 gives me negative, and then I know that these two added up because I set those up here. Great, so I already have the factors. It did factor, so there's no need for the quadratic formula or completing the square. So what I will do then is take each linear term and set them separately equal to 0 and solve them. So 3b equals 1, or b equals 1/3, and then 4b equals negative 3. Dividing by 4, I get b equals negative 3/4.